Sindhu madam, good afternoon.
Good afternoon, sir.
My name is Kannan. I am mentor of IG student chapter alongside Professor Rani.
Yes, sir. Yes, sir. She has told me.
So glad we are getting you as a mentor and a expert for the session.
Thank you so much, sir. Thank you so much. Same here. I am also glad to interact with you people all.
Shall we start with the session, madam?
Sure, sir. It's sharp 3 o'clock, and we shall and we should.
Okay, madam. Hemna, you can start.
Sir, Janita has already joined here. So, Janita, are you here?
Hello. Yes, I'm
here. Yeah, okay. You're audible.
Janita, you may start.
Okay, sir. Thank you. A very warm good afternoon to one and all present here. Greetings from IG Student Chapter, Marine Engineering College, Trivandrum. As we are facing this pandemic situation, we have planned to conduct this webinar via online. Hoping all your support and cooperation throughout this webinar. Let's start our today's session. So today we have Dr. Sindhu J Nair, Professor, Department of Civil Engineering, Bhilai Institute of Technology, on the topic Pro-Environmental Practices for Geo-Sustainable Engineering. Before moving on to the session, it's time to address the gathering. I invite Kannan K, Assistant Professor, Department of Civil Engineering, to propose the welcome speech. Karan sir is the mentor of IG's student chapter and also the executive committee member of IG's Trivandrum chapter and young member of International Society for Soil Mechanics and Geotechnical Engineering. Over to you, sir.
Actually, we have our head of the department, civil engineering, Dr. Vinod, with us. Vinod sir, I request that you may please propose the welcome. Vinod sir, please.
Okay, it's okay. It doesn't matter even if you propose the welcome speech, it doesn't matter. Okay. Anyway, good afternoon to all. Now, first of all, let me welcome everyone who has joined for this online meeting. Today, we are about to listen to the presentation on pro-environmental practices for geo-sustainable engineering. This webinar, as you know, is held under the banner of Students Chapter of Indian Geotechnical Society of our college, Marine Engineering College. And I do know that the student chapter of our college has been actively carrying out their duties, conducting a variety of programs such as quizzes, webinars, and various other student-centric activities. So, in fact, let me take this opportunity to thank the students chapter members and the faculties in charge for making this society is a very vibrant one. Let me move on to my official duty. Today we have with us Dr. Sindhu J Nair, who is a professor in Bhilai Institute of Technology. She is here to share her professional experience on environmental science, environmental engineering, and perhaps on the interdisciplinary area of geotechnical engineering. She has a lot of research publications and funded projects to her credit. Madam, on behalf of the student chapter of IGS, on behalf of the Department of Civil Engineering, and on my own behalf, let me extend a very hearty welcome to you. And also, thanks for accepting our invitation.
Thank you so much, sir.
And the faculty and students of Civil Department, the members of student chapter of IGS, and all other participants present here are also cordially welcomed. Thank you.
Thank you, sir. Now I invite Arya S. Chandran from first year MTech to deliver a brief introduction about today's speaker.
Hello, am I audible? Hello?
Yes, you're audible.
Yes.
Okay. Good evening, everyone, and welcome to the session. The opportunity of introducing a speaker is a great privilege. I would like to introduce today's speaker, Dr. Sindhu J Nair. Dr. Sindhu J Nair, graduate in Civil Engineering from CET, Trivandrum, did her first master's in Business Administration in Marketing but found interest in environmental study and environmental issues. She is the gold medalist in MTech Environmental Science and Engineering and got PhD from the State Technical University, and now working as a professor and is an important pillar of the Department of Civil Engineering, Bhilai Institute of Technology, which is NAC A, NBA accredited and NIRF band 150 to 100. She had published more than 35 plus research papers in various journals of repute and has more than 50 papers to her credit in national and international conferences. She has more than 30 MTech projects, 3 PhD scholars, and 5 funded projects to her credit. She continued to work on various environmental related technical issues in the Chhattisgarh region, and today she is a perfect blend of eminent researcher and academician in the state and region. Sustainability and sustainable development are the key words in engineering, and as a civil engineers, the environmental consideration and pro-environmental practices will be beneficial for all stakeholders. Ma'am, it is a great honor to hear from you this evening about 24 years of professional experience in the field of environmental science and engineering, which intertwined with geotechnical studies, and believe that your experience can inspire the young minds. We are very glad to have you with us. On behalf of all present here today, I welcome you to lead the session. The platform is all yours, ma'am. Thank you.
Thank you so much. Thank you, Arya, for your nice introduction. I heard your name right now, Arya.
Yes, ma'am.
Thank you, Arya.
Thank you, Arya, for your nice introduction, and thank you, Professor Kannan and the HOD Civil Engineering, Dr. Vinod sir, for your warm welcome address. I have to pin myself, right? So now again, thanks to Professor Rani for giving me the opportunity to interact with you all. I think I need to pin my screen. I'm audible, right?
Yes, madam, you are audible.
Yes.
Can you please help her? Are you?
Hi, Sindhu.
Hi, Rani.
Yes, ma'am. I'm outside, so carry on.
Okay, fine. Thank you so much, Rani, for giving me the opportunity to interact with the students of your institution. And I normally look forward to meet the young engineers, budding engineers from different colleges and universities and interact with them. And you people are very special because your college is in my hometown. So I happily accepted Rani's invitation to join you and share my thoughts and my whatever the knowledge which I have gained in these years in the topic, in the subject, in my research works. So I happily accepted because somehow, even though the session is online, I have a feeling of getting connected with Trivandrum. So we can start, I think, right? So Binu, can I have the access to my to share my PPT, please? I think you have granted me access, right?
Yes, ma'am. I have granted.
Okay. So thank you so much. I am also very glad to be with you all. So
Now this session starts. Participants, please note all should ensure that your mic is mute and the video is off. At the end of the session, the participants can ask any queries or doubts, so you can directly put the questions in the chat box. And a feedback response form will also be provided in the chat box at the end of the session. Participants should ensure that you fill the feedback form to issue the certificate. Now I invite Dr. Sindhu J Nair, ma'am, for the session. Over to you, ma'am.
thank you, dear. So what I am going to share with you today is a topic on pro-environmental practices in geosustainable engineering. The developed nations have started realizing the cost of industrialization and hence are giving prime importance to the preservation of environment rather than industrialization. But The developing nations like India, due to the different problems like the population growth and unemployment, still is forced to keep the environmental concerns a secondary factor to industrialization. Throughout history and to this day, pollution touches all part of the environment, let it be the water, let it be the air or the land. Now, when we speak about pollution, normally we speak in the serial order: air pollution, water pollution, and land pollution, right? But here I am mentioning it in the order of water, air, and land. Have posted the photos also in the order of water pollution, air pollution, and land pollution, because water pollution or pollution first manifested as water pollution. Then air got polluted, and after that, the land. The only way to avoid the possible environmental harm from the industrialization is to prevent its generation, or as far as possible, reduce the amount of pollution which is generated. Pollution prevention means changing the way the activities are conducted, eliminating the source of problem. Now, that doesn't mean a negative halt concept. Nobody is asking you to stop the development, halt the development, or go back to the stone era. Of course, development has to happen, but the development has to happen in a smart way, in a sustainable way, so that not just your generation is benefited, but the generations to come also should be benefited or should not be in harm. So it does not mean doing without, but doing the things differently. See, when many of us think about pollution, images of smoggy cities, litter-infested oceans come to the mind, right? True. In the 21st century, there isn't a single surface or space on Earth that hasn't, in some way or other, impacted by pollution. While, see, as in these images, littering and gasoline fuel cars, they are the major contributors to pollution. There are other influences also that are important to be aware of. So to start with, it's helpful to understand the basics of what exactly pollution is. Essentially, when we define pollution, pollution occurs when substances are introduced to the environment that have harmful effects, damaging the quality of water, air, and land. Now, today, as the PG students attending this webinar are from the geotechnical background, and the webinar is organized by the IGS chapter, we will be specifically focusing on land pollution and some pro-environment practices that can be adopted to abate the land pollution. See, land pollution refers to the deterioration of the Earth's land surfaces at and below the ground level. Not just the land gets affected. Of course, the solid pollution or the solid waste disposal over the land will contaminate the ground below as well, the water below as well. And it wasn't until the mid-20th century these solid waste were neither collected nor disposed with keeping in mind the environment. Unsegregated collection of solid waste proceeded. Even now in many places, the practice is still going on. So prior to, at least nowadays, we are a bit aware of the segregation mode of the solid waste management. Prior to that, waste was typically collected together, unsegregated, collected together, and then simply disposed of on top of the ground, or many times even disposal deep inside the oceans. And this resulted in many diseases, some accounted for the disposal, and some diseases even wasn't identified as attributed by the solid waste disposal. Yet, while there are now significantly many safer practices of disposing the waste, there are still many other factors that are contributing to or still worsening the situation. The cause is the accumulation of the solid and the liquid waste materials that contaminate groundwater and soil. These materials could be hazardous or could be non-hazardous, and the risk associated with the land pollution and with the groundwater pollution, major factor depends upon the permeability of the soil. Lesser the permeability, lesser will be the risk associated, and vice versa. Greater the permeability, greater will be the risk associated, and greater will be the contamination in the groundwater as well. Now, these are the different solid waste disposal methods which are normally adopted, polluting the land as well, disturbing the land features as well. One is the landfill, other one is the incineration, another one is the composting method. Now, see, all these three methods have their advantages, but at the same time, disadvantages as well, provided they are not being carried out in a technically sound manner, or provided they are not being constructed in a properly designed way. Experience has shown that there is no completely safe method of waste disposal. And all these forms of disposal, you name 1, 2, 3, or any other, all these forms of disposal have some negative effects on the environment, public health, and of course the local economies. Landfills have contaminated the drinking water. The garbage burned in the incinerators are found to poison the air, soil, and water. Now, the composting pits, if not made in a technically sound manner, leaches into the groundwater, contamination to the air as well. So, we need to adopt some pro-environmental practices so as to ensure the environmental sustainability. For that, we may need to shift to certain renewable resources, limiting consumption of the non-renewable resources. Then the environmental decisions or the choices made must be of long-term consequences. Don't aim for the short-term consequences or one which will be fitting for one generation. Actually, whatever decisions or choices made should be beneficial for the generations to come as well. Then, the social welfare has to be targeted, not just the economic welfare or the GDP when economic choices, environmental choices, and decisions are made. Then, health of the ecosystem can be protected, has to be protected by using products that minimize the waste or are non-toxic. You can compost or anaerobically digest the biodegradable waste. You can reuse materials, either on-site reuse can be done or materials could be collected and utilized for off-site recycling. So, what I mean to say is that we need to adopt different approaches for the implementation of certain environment-conscious practices that may prevent or reduce. I may not say 100% prevention. It may reduce the pollution load on the environment. Now see, this image talks about the time taken by the different products when they are disposed over the earth. In the extreme left end, you can see the organic products or the food products, which still takes about 1 month for their complete degradation. Whereas in your extreme right, you can see the glass, which takes over 1,000 years of complete degradation, of complete decomposition. Now you have seen the brick or the concrete waste that may take up to 100 years for their decomposition. So you can see over here, there are so many products that turn to be an environmental nuisance after their fair use. Now, students, when I say the word fair use, the word fair is used when the product is actually serving. The word fair is used when the product is actually serving the purpose it is intended for. Now, say for example, if you are buying sauce in a glass bottle, until the sauce is there in the bottle is serving its fair use. Now, once the sauce is finished, now the bottle is a waste. So, as far as possible, if you can put that bottle into some other beneficial use. So now the term is not the fair use, it's a beneficial use by reusing the same bottle, or if possible, recycling the same bottle. So that is what the pro-environment activities mean. So therefore, you just stop a while, gaze around you, and you can identify hundreds of such problems that need solution and thousands of issues that may manifest in the years to come. Now, this is the scope of the research projects as well. Let it be the BTech project, let it be the MTech project, or the PhD researches. You have to identify the possible approaches that could be made to gain positive results for the proactive behavior against the pollution around you. And now, luckily, the course you are specializing is very much related to the earth and its atmosphere, the land above and below the ground. So, pick any of the issues that seem feasible and plausible and start working on it. And of course, at times, the research may not be fruitful because, see, research, as they say, is just like exploring a black hole. At times, you may find the light at the end of the tunnel. Many times, you may not. But don't be disheartened. Try another path or the alternative and proceed. At the individual level, there are many things we can do to reduce the contributions to land pollution. One of the simplest ways to do is, just as I have referred now, either you can reuse an item or recycle. If not for the fair use, you can put it to some other beneficial use. And now, as civil engineers, as environmental engineers, as geotechnical engineers, if you are looking to make a difference on a community level, if you have to do some contributions to the society as researchers, you can do many researches and become an environmental steward in your neighborhood. Now, when I am talking about pro-environmental practices, when we are talking about the solid waste disposal over the land and the corresponding land pollution, we have to check the solid waste management hierarchy. The most preferred level is on the top, which is indicated by the dark green color triangle, that is the reduction. Reduction is the most preferred one in the waste management solution. That is the need not to use virgin material from the nature. Now, if it is absolutely impossible to reduce or to avoid the use, you can reuse the commodity rather than throwing it as an environmental burden. You try to reuse it, or if not possible, you try to recycle the object. So now we are down the ladder by step number 1, 2, and 3. But my dear students, we now are still in the bottom zone of open burning, that to unsegregated open collection and burning of the garbage, which is of high environmental risk and unacceptable. It is the least preferred step as well. Now, as civil engineers, you can achieve the reduction in the waste during the different construction process by ensuring maximum resource recovery and safe disposal of the waste so that the burden of the landfill becomes reduced. You can segregate the waste efficiently using different colored bins for collecting the different categories of waste from the construction process. So now I'm going to discuss some pro-environmental researches, certain glimpses from certain researches done by my few scholars in the PG program. See, I never force any specific topic on my projectors or my scholars to find the solution. Instead, I ask them to look around and come up with some issues around them that they feel is urgent to be sorted or feel it essential to find a solution. So, if you look around, surely you will come up with issues that need attention or rather immediate attention. So, once you have identified the problem, the next step is to find the possible solutions. Now, again, one thing, whenever you go for the solutions, try as far as possible to end up with some feasible solution. Feasible solution means try as far as possible to go for something which is indigenous so that the project or the research or the end result is economical in the long run. So this is actually where the challenge is. If you go for some foreign material which is not available in your place maybe all through the year, so then how can you get the work implemented? So one of my scholars who is working with FSNL. FSNL means the Ferro Scrap Nigam Limited. He used to witness the slag being dumped, steel slag being dumped from the Bhilai steel plant onto the open ground just near the boundary wall of his office. Thus, the idea of adding the slag as a replacement of aggregates and concrete would have come to his mind, and he discussed this with his superiors, then consulted with me, and we got the slag tested for the appropriateness and suitability. And the outcome of this work was very much appreciated, and he got it published in the international journals of repute. So this is the first research discussion we will see now, that is reduce from the 3 R's. A research on the sustainable utilization of steel slag of Bhilai steel plant for concrete pavements. The production of 1 ton of steel results in an average of 400 kilogram of byproducts. You just imagine the volume of byproducts which is formed, and these include not just slag, but slag, dust, as well as the sludges and other materials. And nowadays, as industrialization has increased, steel production also has increased multifolds, and consequently, higher volumes of waste also are generated. And the biggest problem is the land which is required for the disposal of the slag as well as the sludges. So, if the waste could be utilized, let it be the slag, let it be the sludge. If any of these waste could be utilized, it can produce economic benefits, of course, and if you can provide some sustainable solution that can allow the steel industry to achieve the target of zero waste. So those who are in the BTech people will be understanding, I think, what the zero waste emission is. Zero waste emission means whatever be the emissions which are produced within the industry, if it is possible to get those waste recycled or reused within the industry itself or some other process, then you achieve the zero waste target emission, and then you will be satisfying the environmental policies and legislations as well. So see here, the slag is generated as a byproduct in the production of a specific type of steel. So as such, you will have the different type of slag from the different processes like from the basic oxygen furnace, electric arc furnace, and the open hearth furnace, the nature and the characteristic of the slag produced will be different. So the slag which is available, which was available for our work is from the blast furnace, and a huge amount of iron and steel slag is dumped in the yards of each production unit, engaging important agricultural land and grave pollution to the whole environment, especially the land. In India, the current production of steel slag is around 12 million tons per annum, and most of the slag produced in India, especially the steel slag, is discarded. Outside India, the usage of steel slag includes they are using the slag as aggregate for road construction, as rail ballast for the paver blocks in the bricks, etc. So an efficient approach to overcome these problems is to utilize the slag which is available. And of course, for the utilization, you need to know the physical and chemical characteristic of the steel slag. That has to be decided in order to make it used as road aggregates, cement and concrete admixture, etc. See, the objective of the study was to find the applicability of steel slag. This is a problem-specific research done to find the applicability of the steel slag from the Bhilai steel plant and other similar steel plants to find the solution for the specific problem of slag management and its disposal, thus saving the environment. You can see the Bhilai steel plant in the photograph here at the far, and this is actually the dumped slag. Now, the methodology adopted in the research was the procurement of the slag, then the crushing of the slag to 20 mm size aggregate, then mixing of the slag means proper mixing, proportioning of the slag with the regular constituents of the concrete, then curing the concrete blocks, and then testing and making the evaluation depending on the results. So the mixed proportion used here was 1:1:2. We adopted the nominal M25 mix, and the water cement ratio was 0.5 by weight. I'm just summarizing and telling you the results. The first one was the normal specimen, standard specimen, where 0% of the slag was used, and the aggregate used was 100% the coarse aggregate only. Then 20% of the slag was introduced into. Then the third step was a 50% introduction of the slag into, and the fourth was the risky one, where 100% of the slag was made to replace the coarse aggregate, and the properties were analyzed. Now, before casting the cube, first of all, as I have told you, the slag has to be tested for its appropriateness. Means, for the intended use, if he is proposing it to use as a concrete pavement, it has to prove its appropriateness. So for that, the steel slag should be tested for the similar parameters of the aggregate as well. So the test was done for crushing, Los Angeles abrasion test, impact value test. You people know better than me all these values. Those who are actually specializing in the stream, specific gravity and water absorption. And the slag specimen, the crushing value was more than the normal one, normal aggregate. The specific gravity also was within the range only 2.93, water absorption also very fine, and the abrasion and the impact of the slag specimen was much better than that of the natural aggregate. So see, this is the result of the average compression of all cubes with different percentage of slag. So the first one was the standard specimen and the average compressive strength here for 7 days and 28 days. Now this for the 20% replacement of the slab, this for the 50% of replacement, and this for the 100% replacement of the slag. See, the average compressive strength was more in the for the 28 days, after the 28 days, in comparison with the standard specimen. Of course, the value was highest for the 50% replacement of the slag, but again, all these values are much above than the value which is required for M25 mix. See, the concrete cube casted using slag as aggregate, achieving strength much higher than the requirement of the design mix M25. The value was highest with the 50% slag being used as a replacement to natural aggregate. Slightly decreased with the use of 100%, but still it is again greater than the value which is required. So now for the next one, next R, that is reuse. There is rapid pace of development in the world in the various fields due to urbanization, industrialization, modernization, and infrastructure development. And all these are generating substantial volume of construction and demolition waste. See, even the building debris can be put to good use, like filling the potholes and laying off the roads. Now, another scholar, as she was walking to the department from the parking lot, she witnessed a heap of concrete waste and tile waste outside the lab premises. Actually, that time only one working platform of one lab was demolished and reconstructed, and the lab and all these waste were dumped along the side of the lab itself. So this is the second research we are going to discuss now, a project on the reuse of construction and demolition waste and rice husk for sustainable engineering. So this scholar wanted to do something more than just construction waste. So that is where this rice husk come into the role. I'll discuss about it. See, the construction and the demolition waste is generated during the construction, maintenance and disposal phases of a building. It includes waste from demolition of the structures, renovations in the real estate sector, construction and repair of the roads, flyovers, bridges, etc. According to a report from the Ministry of Environment and Forest, it's estimated that in 2018, 292.4 million tons per year of waste is generated in the country. And this is the chart of the waste which is generated in some of the major cities in India, as given below. The massive construction activities as well as the waste generated cause environmental problems such as carbon dioxide emissions, illegal dumping of the construction demolition waste in the landfills, depletion of farmland and natural resources, and the reduction in the value of the land, availability of the land as well. Now, see, as I have told you, the scholar wanted to do something more than just the analysis of the construction waste, because similar project has been done even before as well. So, we looked out for some other waste that was a potential pollutant in our region. Now, as many of you may be knowing, you may have learned in your general knowledge as well, Chhattisgarh is called the rice bowl of central India. And we have about 20,000 varieties of rice here. And obviously, you can imagine the number of rice mills as well. There are so many rice mills here. And all these rice mills, of course, the main process is the removal of rice from the husk, and the rice husk, which is the outer covering, comes out as a waste. True. Now, during the milling of paddy, about 78% is received as rice, whereas the 22% of the weight is received as husk. Now, in the rice mill itself, this rice husk is reused. Partially it is reused. They cannot use the complete rice husk, of course, but they may use just partially used for the parboiling process. Now what comes out will be the ash. And now this rice husk ash is a great environment threat because it causes damage to the land wherever it is dumped in the surrounding area. And so if this rice husk ash can be brought to some use in the civil construction practices, in any case if it is possible. So that initiated this research work. The main purpose, as I have told you, was to investigate the potential replacement or reuse of coarse aggregate by the construction waste. What we had in our hand was the concrete waste and the ceramic tile waste. Other part of the study involved the usage of the ash received from the rice husk. The research partially involved the partial replacement of cement by the rice husk ash. The raw materials adopted were the 20 mm coarse aggregate, the concrete waste and the ceramic tile waste, both broken to 20 mm size, the rice husk ash, water, and the mixed proportion we adopted in this research was the M15 mix, 1:2:4, and the water cement ratio of 0.5. See now, this is the methodology of study done in 3 different heads. First was for the standard specimen, where only cement and the normal coarse aggregate was mixed. Now here for the second one, the 50% of the construction waste replacing the aggregate. Third, 100% of the construction waste, and then 50% of the tile waste, and then the 100% of the tile waste replacing the normal aggregate. And the third part of the study was the replacement of 10% of the rice husk ash with cement and 20% of the rice husk ash with the cement. Now, I tell you, she got positive results until about 24% of the replacement of the ash with cement. But when she tried the 30% replacement, it was not a success. So we stopped the research findings and the results with 20% only. See again, tubes were casted and tested for 7 days and 28 days of curing. One with the standard specimen, average specimen seen over here in the green font here. And see the table, 50% coarse aggregate replacement and 100% replacement with the concrete waste. Then the tile waste. See here, the tile waste did not give us much satisfactory result. Rather, it was very down. And now see, what about the 28-day compressive strength? Standard specimen gave a value of 30.81, and the 100% coarse aggregate with the concrete fetched a value. Obviously, the mix taken was M15, so the strength obviously went greater than what is required, both for the tile waste. But somehow we didn't feel that much satisfactory. But again, for the 28-day strength, this also gained considerable strength. Now with the replacement of rice husk ash. Now here at 30%, again I am telling you, this was giving a lesser value. So limit it up to 24 or 25. Now see, for the third R of the 3R of the solid waste management hierarchy is a recycle. Now, drifting from the away from the first 2 cases, that is a solid waste disposal on land. Now I'll be discussing on something which is my specialization on the wastewater engineering. This is the topic on the wastewater recycling. Now this scholar, he is working in PHED, Public Health Engineering Department, and he wanted to do something with regard to the saving of water. Saving of water means that too, especially the grey water which is just disposed or made to run to join the drain if it is possible to recycle that grey water. So that was the thought which led to this particular. So I am slightly drifting away from the solid waste disposal on land. Now I am talking about in this 3R concept for the recycle. I will be talking about the recycle of the grey water, especially the kitchen wastewater which is used in our homes. See, recycling can prevent the waste of potentially useful materials and reduce the consumption of fresh raw material. So here, the fresh raw material is the fresh quantity of drinking water which is supplied to the consumers from the water treatment plant. And we literally at our homes, we use the potable drinking water for practically everything in the house. Let it be for cleaning the cars, let it be for washing the clothes, washing the garages, gardening purposes. We use the potable drinking water only, and we are literally flushing our drinking water down the toilet or making it impure by all these uses. So the kitchen is one of the important factors of water pollution. If the kitchen wastewater can be recycled to some beneficial use in the house itself. So why? Because every drop counts. That is the reason why we had a thought to recycle the grey water. And now those who have done their engineering and those who are in the final year of the engineering, those who have studied the subject environmental engineering will be understanding the difference between these two terms of grey water and black water. Grey water is the wastewater from the non-toilet plumbing fixtures like kitchen sinks, showers, wash basins, etc. So, now again, since last about 1.5 years, we all are washing our hands regularly to stay safe from the coronavirus pandemic, right? But we cannot afford to take the water for granted by leaving the taps on for this 20-second of cleansing routine. Approximately 50 to 70% of the water used in our houses result in grey water generation. Only a very small quantity is flushed down the toilet. So, but very unfortunate that not even 5% of this is recycled. It is also it also runs to the drain only or the sewer pipes only. So this water, if it is made suitable for in situ recycling using some simple low cost technologies, and it is actually rather unfortunate that the concept is not common in a water starved country like India. See, sitting in Trivandrum, you may not understand what actually water starvation is. And very fortunately for me also, the place where I live, I never have faced water starvation, but there are different places in India, especially North India. There are so many places which are water starved. The availability of drinking water is very less. So this was the spark actually that led for the research work, and I'm going to discuss with you. See, recycling of the kitchen wastewater by phytoremediation. See, phytoremediation is the name given to a set of technologies that use plants to clean contaminated sites. In this project, the term phytoremediation refers to a set of plant contaminant interactions. So actually, as you all know, for the MTech, the maximum time which is available for the research work is 1 year. And in this 1 year, I think he have done the research for about 8 to 9 to 10 months. So in this concept of phytoremediation, long-term objective field evaluation is essential to understand how well the phytoremediation may work and what the real cost of application will be. And you have to build the models to predict the interaction between the plants and the contaminants. So 8 to 10 month work is the one which I am putting before you. And he has now started his PhD research also under me. So maybe we will be getting a better and a clearer vision of what exactly the result will be in maybe the next 3 to 4 years. See, phytoremediation is a technology that uses various plants to degrade. Certain plants is able to degrade the organic matter which is present in the water. Some plants extract the degradable material from the wastewater and then contain it in their body parts. Let it be the roots, let it be the stem or the branch or the leaf or sometimes the fruits. And some plants immobilize the contaminants, immobilize and let it not move from one place to another, from the soil and the water. Of course, toxic heavy metals may not be degraded by the plants. So that is the reason why we focused on the organic pollutant or the organic wastewater from the kitchen as our subject of research. So, see, the most commonly used growth media in phytoremediation is gravel or soil. See, gravel, as you know, gravel filters are effective in removing the suspended solids from the contaminated water. And it is less effective in removing the dissolved nutrients. So the sand and the gravel layer removes the bacteria as well as the small particles from the wastewater. See, this is the experimental setup which he has constructed in his home only. Now, first of all, what was done was the kitchen wastewater. Kitchen wastewater or the larger floating solids in the kitchen wastewater was filtered and the kitchen wastewater was lifted manually over here to this tank. You can say it as a tank or a tub. And then the filtered wastewater was filled in the tub and then the wastewater was made to flow. Depending on the velocity, he controlled the velocity using the peristaltic pump. So the water was made to flow from the top below to the two tanks, which was the experimentation tanks, tank or tub, whatever it is. So these are the two arrangements, and in the first tub it was the gravel which was placed, and this is the second where the sand is being placed, and this was a macrophyte which was used in the filter media. The raw water at this particular tank was tested for the parameters, and the water at the outlet over here after the second tank was analyzed. This effluent was analyzed for the removal efficiency. Whatever be the parameters tested for the removal efficiency, the inlet parameter was measured from here and the outlet parameters was measured from the effluent which was collected over here. Now, water automatically passes from this tub to the first one and then filtered down to the second one, and then the effluent is collected from here. Now the macrophytes in the second tub, the macrophytes are grown. Macrophytes have a significant effect on soil as they slow down the water flow and trap the pollutants in their stems and the roots. Now the macrophyte used was water lettuce. Water lettuce or water cabbage is capable of removing the nutrients and the heavy metals from the contaminated water bodies. So, the young plants, the problem is the macrophytes were growing out somewhere on the pond. But the main thing is that these plants has to be acclimatized with the water we are treating. For that, the young plants of the water lettuce was collected from the local area, and these plants were immediately transported to his house and then rinsed with the borewell water. In his house, the common usage was not from the municipal supply water, it is from the borewell itself. Over here, in every house, we have this two two connections. We all have the borewells at our individual homes as well. So in his house, the major usage was from the borewell. So this macrophytes has to be acclimatized to the water in which it is treated. So for that, what is done? About 3 to 5 days, these macrophytes were placed in a tub containing the borewell water under sun. So after around 3 to 5 days, these plants got adapted to the water into which it is to be treated, and then he replaced it to the filter medium for phytoremediation experiments. The first study was for the treatment of the kitchen wastewater by using the microphyte. The efficacy of the macrophytes were tested. Now see, this was now again I am putting before you only a small table, but again it is a result of the extensive research work which was done till around 10 months, again for the PG project. So this is the average result of the sample which I am putting before you. The inlet sample, the kitchen water, wastewater was somehow a bit acidic, and BOD, total dissolved solids, and the suspended solids was the parameters which he has tested. Some more parameters, but I am now putting before you only these four which are actually considered to be the crux of the efficiency. You have to deal with these four factors and the outlet sample. See here, as I have told you before, the dissolved solids removal was a bit lesser. Suspended solid removal, the gravel and the sand filter and the macrophytes have done a good job. Even for the BOD removal is very good. Acidity also, the water turned to the perfect normal pH. Now, the second part of the study was the analysis of kitchen wastewater. The same wastewater was made to stand in the filter media for different hydraulic retention times. Hydraulic retention time, as you people may be knowing, is the average residence time for the fluid particles if it is provided steady state outflow conditions. So the water is made to stand still in the pond for a period of, say, or either in a very smaller velocity. The hydraulic retention time was managed for 6 hours, 24 hours, and 48 hours. And again, the efficiency of particle removal was analyzed. See, this was a pH of the inlet sample, BOD, and total dissolved solids and suspended solids. Now, in his findings, we could see that the removal efficiency increased as the value of the hydraulic retention time increased from 24 hours to 48 hours. So, in 48 hours, you could get considerable removal efficiency of about 30 to 80% of BOD was removed. And total dissolved solids, the value is a bit lesser because dissolved solids removal was only about 50 to maximum 60%. And the suspended solid removal is about 40 to 60%. Now, the third part was the analysis of the same water by introducing different plant species. Now, if you Google for the plants best for phytoremediation, Google will give you a list of plants, and it will tell you, as far as possible, many broadleaf plants will be good for phytoremediation. And the selection of the plant should be based on the pollutant tolerance potential. The plant should be able to bear the load of the pollutant and oxygen carrying capacity, and of course removal efficiency, because that is what we are aiming for. So, see here. Again, repeating the same thing I have told you a few minutes ago, whenever you are doing a research, as far as possible, try to adopt indigenous raw materials which are available for you the year long. You have to try to think of the solutions which is feasible in the region where you are, in the area of the country where you are, or the world where you are. So see, water hyacinth and sunflower. Among the list of the different plants we got from Google, of course, we selected two plants, water hyacinth and sunflower, because these two plants are plentifully available and very easy to grow. Water hyacinth you can find everywhere. In Kerala, it's too much of availability is there. Same with here also, as well as sunflower. Was the two plants which were selected for phytoremediation. Now, what was done is he constructed two beds in which water hyacinth was grown, in the other bed sunflower was grown, and water was slowly made to sprinkle over the water hyacinth bed, and the effluent also was collected using a set of under drains. It's not so easy, as I say. Water getting infiltrate down through the soil and collection of effluent is a very bit difficult task. You have to adjust the velocity as well. Anyhow, that's a part of the research work. From the hyacinth bed and from the sunflower bed, the effluent was collected for and checked for the efficacy of the removal. Now see here, this is the average results of phytoremediation on different plants. Now here, see, just have a look at this table. I cannot tell you a clear-cut differentiation of which one is superior over the other one. I cannot say that water hyacinth is superior over sunflower or vice versa, because as you can see, the BOD reduction is more by water hyacinth, whereas the total dissolved solids and the suspended solids removal, it was better by the sunflower, or rather from the sunflower bed. So that is why I told you much extensive study is required to find out which one is efficient, or actually this again I can say that the selection of the plant and the adaptability of the plant will be can be based on the type of the water which is to be treated and the intended level of purity which is required. So of course we are involved in the long-term and extensive study, and for now, see, both the plants were good in the removal of some specific characteristic. Here, BOD was removed by the water hyacinth, more considerable differences there. And then for the total solids and the suspended solids, the sunflower proved to be a better one. So, depending on the quality of the effluent which you receive after the treatment, means the level of purity which is achieved after phytoremediation, the recycled water can be mixed with the natural water supply or added to a reservoir or a ground aquifer, or it can be stored and blended with the regular water supply depending on the purity which is available. And since the water which he received was only about, I think BOD removal was around 45 milligram per liter only, he used the water for his rooftop gardening. So the water can be very well used, and the place where we live here in summer, especially this particular summer month, was very scorching heat, and we need to water the plants in the balcony at least twice. So you just imagine the amount of water which is running for this purpose. Again, is the potable drinking water which has been treated up to the drinking water quality standards, right? So if you can recycle the used water, spent water, let it be the grey water only. So then it will be a very good consideration of the drinking water you are saving. So now, to end with my technical session, some thoughts to take away. Solid waste management in our country needs serious thinking and sincere efforts. See, the sector has remained neglected despite the awareness regarding its ill effects and intervention by various authorities. You have so lot of conferences, SDPs, faculty development programs being conducted for solid waste management. But I say very few are implemented. If you happen to travel by road across the different cities of the country, you can see how pathetic the situation of the solid waste management is. Today, not only the country, but the entire world needs to conserve the energy to fulfill its needs and offer a quality life. My dear students, you are the next generation of planners, builders, and designers, and you hold the key for the better future. Take the challenges, grab the opportunities coming your way, keep learning, keep updated to the new technologies because technologies get revised and updated in a matter of, say, 5 years or so, and have a very bright future. Let us all work towards sustainability goal with matching efforts. The sustainable engineering journey, sustaining of our mother nature is a journey, not a destination, and there are no shortcuts. Thank you all for very patient listening.
Thank you, ma'am, for a wonderful and very informative session. Now the platform is...
Hopefully, I didn't bore you people, right?
No, ma'am, no. It was interesting.
Thank you so much. I intentionally kept it light only because, see, I'm not the core geotechnical engineer, and this program and the PG students, all of you over here are from the geotechnical background. I can only combine the work for geoengineering or geo-environmental engineering. So I intentionally kept my presentation in a lighter way so as to incorporate the BTech students as well and you people.
Thank you so much, ma'am.
Yes, madam. Thank you. Thank you, madam. Exactly. We have participants
from the BTech
S4
as well.
Today. Yes, from S4 also we have participants today from
yes,
S4, S6
yes,
and S8. So,
so I hope
all of the students
okay, sir. Yes, sir.
Yes, sir. So, madam, so that is what I was also saying, that our students have also, I hope they have also really got inspired from the efforts that you and your students are actually doing to, in a manner as nature police, shall I say,
Thank you, sir.
Preserving nature. So, thank you, madam. The talk was really enlightening. The session may now be open to discussion. If there are any queries from the students.
Hello, ma'am. Good evening.
Good evening.
Ma'am, now for the past decades, we have been hearing about green building, something called green building. Is that what something related to this pro-environment practice?
Of course. Green building means when you are employing the practices which are green. The practices which are green. Green means which is causing minimum harm to the environment, the building becomes green. In terms of electricity expenses, in terms of plumbing fixtures and all, when every part of the building is constructed based on the environmental concerns or keeping in mind the environmental concern, the building becomes green and you get certified for the green building.
Any more queries or doubts from the participant side? Okay, now the participants can share the feedback. You can unmute yourself and share the feedback about the session.
Good evening, all. I'm here to give my feedback on the topic pro-environmental practices for geo-sustainable engineering. It was a very informative and enlightening session for us, And I think it helped the students present here to make more awareness about the topic, sustainable management, sustainable environment and waste management, about 3 Rs, etc. And it was very interesting. Thank you.
Thank you.
Any more participants to share the feedback?
Ma'am, we had a really good time this hour. And the concepts and materials like you presented were like land pollution, phyto remediation, all that will definitely be helpful for all the young engineers here. A lot of enthusiasm, very important for our career. Thank you, ma'am.
Thank you. Thank you.
Good evening, all. Thank you, ma'am, for your enlightening informative session. We really enjoyed the program, and the concept and material presented will definitely be a valuable information to our career. Thank you, ma'am.
Good evening, ma'am. Thank you so much for conducting this webinar. It was really very informative. The basic knowledge required to upskill ourselves in this particular domain was achieved today. This was a really inspiring and fun session. Thank you so much, ma'am.
Thank you.
Any more participants to share the feedback? Okay, now I welcome Nimisha Aryu from first year MTech to propose the vote of thanks.
Good evening to one and all. It's a great honor and privilege to express vote of thanks for today's session. First and foremost, let me thank our special guest and speaker of the day, Dr. Sindhu J Nair, for a wonderful session. I'm sure that the knowledge you shared may definitely benefit us in our future. Thank you, ma'am. And also, I express my gratitude towards our management, head of the department, faculties, and members of our chapter for their encouragement and great support. And also, I express my gratitude towards the organizing team for the great effort in making this event a grand success. On the behalf of entire student chapters of MEC, we thank each and everyone who participated in this section. Last but not the least, let me thank the God Almighty for making this webinar a grand success. Once again, thanking you all. Thank you.
Thank you, Nimisha. Participants, please note that the feedback form will be provided in the chat box. Please ensure that you fill the feedback form to issue the certificate. Now, as a token of gratitude, we present a virtual memento to you, ma'am. Can we have it on the screen, please?
Thank you so much.
This is presented to Dr. Sindhu J Nair with deep appreciation for your visionary guidance and in recognition for your enduring commitment throughout this webinar. We thank you for spending your valuable time with us. Thank you. Thank you, ma'am.
It has been a pleasure to be with you people, to getting in touch with you. Any doubt, any queries, you can contact me. Thank you so much.
Thank you once again, all the participants and faculties for joining this webinar. Thank you all.
Thank you. May I leave?
Yes, ma'am, you can leave. Thank you.
Yes, madam. Yes, madam. Thank you. Thank you very much.
Thank you,
for
sir.
the enlightening session.
Thank you, sir.
Thank you, Sindhu.
Thank you, Rani. How are you?
Yeah, just out of the hospital. I'll call you in the...
I'll call you. I'll call you.
Okay. Hope
Thank you so
everything was
much,
good.
sir. Thank you. Thank you. It was a pleasure interacting with you all. Thank you. Thank you. I'm leaving the meet.